Now onwards, we will be going through environmental engineering. Okay, this is our environmental engineering. In this one, quality of water, source of water, water supply, purification of water, distribution of water. This much is a water supply and need of sanitation, sewerage system, circular sewers, over sewers, sewer apparatus, sewage treatment, surface water drainage, drainage. This much is a wastewater. Then after that, there will be a solid waste management types, effects, engineered management system, air pollution. This much is a solid waste management. Then after that, air pollution, pollutants, causes, effects, control, noise pollution, etc. This much is your air pollution. From here, noise pollution, causes, health, effects and control. Means totally we have here water supply engineering, wastewater engineering, solid waste management, air pollution and noise pollution. Okay, these two are very small chapters, and this is also somewhat medium small, but these two are somewhat big chapters. Okay, and whatever they are included here, rather than going through that syllabus, we have to study everything. Means everything means not all, whichever which is very important in and considering diploma level, that level we have to read, right? Then we will go one by one. Today we will be covering Today we will be covering sources of water supply, then water distribution of water, and if time permits, I will go through quality of water. Okay. Then purification of water, that is a treatment of water, that we will see tomorrow. Right? And here sewer appurtenances are there, but these and a little bit of water appurtenances both are somewhat same. Therefore, today we will go through this also. Okay. Most of the theory thing we are covering today. Therefore, I will be providing that notes later to you. Therefore, I will be going through, that is reading the notes, and along with that, wherever that is important, I will stress there itself. Okay. And today there won't be any problem solving. Therefore, we will be going very quickly. If I cover quality of water, then I will cover problems. Okay, now we will go through the first one. See here, water treatment. Water treatment or otherwise water supply or environmental engineering we are studying. Correct? Environmental engineering. Environmental engineering, in this one we will be having, we have to deal with the water, and we have to deal with the air and noise. Okay, apart from these, there are many aspects that comes under environmental engineering. Those who do BE in environmental engineering, they will be covering most of the syllabus, that there will be many chapters, many subjects in that BE as a environmental. But we are civil engineering students, and we want very important things, or otherwise the points which are required for civil engineering point of view, those only we are studying. Therefore, this air pollution and noise pollution also we are not going very deep into this one. Just concepts and terms are important terms that we are going through this air pollution and noise pollution. In environmental engineering, most of the time civil engineers are dealing with the water. Therefore, this is a water supply, and wastewater engineering is a very important. And whenever I deal with the waste, there are many types of waste that we will be going through. This many types of in this many types of waste, that liquid waste will come, and solid waste will also come. Liquid waste, I will consider it as a sewage or industrial waste management or waste water. Then solid waste, I have a separate chapter for this one, solid waste management. Right? Like that, semi-solids and all other solids also comes, that we will not be covering. Therefore, mainly the water supply and wastewater or solid waste, that is our main aim. Now, what is water supply? What is water supply? Water supply means, here let us consider there is a one village or otherwise town or otherwise one city, whatever it is. There are some that need is there here. It might be a factory also, not only a village domestic, it might be a factory, industry, whatever it is. There is a need here and we need to supply water to this area. Then where I have to collect that water? Then I will call this point as a source point. Means from the source I will get the water, and that water I have to supply to wherever it is needed. Now in between this process I cannot directly transfer supply this water from the source to the need, because this water may be impure. Water may be impure, and in this need also there is some demand of some chemical composition and all. Considering reading or otherwise studying all the demands required in the need, and considering all the chemical qualities required in the need place, then considering studying all the quality of the water present in the source, then I have to arrange one treatment plant. Okay, that I have to arrange something called as a treatment. Means I have to treat the water, remove excess minerals or add that shortage minerals, then you have to prepare the best water, drinkable water. That water we have to supply here. This is our main aim. And whenever you treat this water, then you have to collect that water, and after that you have to pump to the villages or towns or wherever it is required. This is all about water supply scheme. In this water supply, this chart will explain you very briefly what exactly in this water supply scheme we are going to study. The first thing is that intake structure. Intake structure means some sources will be there. That source, from that source we will be pulling the water. We are just sucking the water, and that water we will be following that allowing through the screens to remove big particles, and those that filtered water or otherwise the water with free of this one big particles will be pumped, and it will be allowed to treatment. The first treatment, it might be a coagulation, and after that come flocculation or sedimentation, and after that filtration, and after that post chlorination, fluoridation, like that many. Okay, here only few are mentioned. There are many treatment units will come in between. Then after that, that water will be pumped to the overhead tank. This is considered as a overhead tank, and the water is stored in this overhead tank, and from this overhead tank the water is supplied to the home or factory or industry. This water is supplied. This is the entire scheme of this water supply. Okay, don't go by this chart. I will be giving that water supply chart later. Then what exactly we will be having, that what exactly the units we will be having in this scheme, that we will be sharing. This is just a brief that the journey starts from intake structure and enters the journey. Okay, not much covered. The journey starts from intake structure. The journey starts from intake structure, and it will undergo many the treatment units, and after that it will be going to overhead tank. From the overhead tank the water will be distributed. Right? This is a brief. Right? Then coming to the first one, the source. We have to identify source for the water supply. Then we have to identify, generally we will be having two types of source. The first one is surface source, and the second one is subsurface sources. Surface sources means the water is available on the surface of the earth. Let us consider this is your earth, and this is your surface. Okay, your water body is available on the surface of the earth. On the surface of the earth. Okay, it might be ponds, it might be lakes, or it might be streams or rivers, storage reservoirs like dams, culverts, or something like that. Then after that we will be having oceans. These are all considered as a surface sources. Then what about subsurface sources? In this subsurface sources we will be having springs, karanji, No? Then infiltration galleries, infiltration wells, or wells, then tube wells. These are all called as a subsurface source of water. Right? There are two types, surface source and subsurface source. Now, just I am included the images so that you can see the ponds and lakes. What is the difference between the ponds and lakes? The ponds are smaller and lakes are bigger. That's it. The ponds are very small and lakes are very big and deep. Right? Then you can see this figure. Here you will find streams and rivers. Rivers are big in dimension and streams are small in dimension. That's it. Okay. This you can call it as a ಕನ್ನಡದೊಳಗೆ ಹಳ್ಳಗಳು ಮತ್ತು ನದಿ. Right? Then after that we will be having storage reservoirs. Storage reservoirs are man-made reservoirs where we store water. This is your dam structures, dams and all. Then after that we will be having ocean. Ocean is a that you will be seeing sea or ocean, that is this one. Then after that springs. Springs means the water will be coming from the ground. Here groundwater is there, and because of some capillarity or otherwise pressure from the water, then the water will be coming out of the this ground. This is called as a spring. Okay. Then after that infiltration galleries. Infiltration galleries are something like this. Look at here. This is a sea. This is the sea water, and this sea water will that infiltrate through the soil, and after that engineered coarse sand. Here we will put a coarse sand so that the water will penetrate here. Then after that the water will come here, transmits intake transmission pipe. Then after that I will be taking. This is infiltration gallery. Okay. Then after that we have a infiltration wells. Infiltration wells are something like this. Here this is a infiltration well, and here you can see there is some sand bed is there, and this is a pipe here. This is a pipe. You can see here gravel beds are there, and here some meshes are there, so that water will pass through this one. Infiltration galleries and infiltration wells, what is the difference between these two? Then infiltration galleries are also called as horizontal wells. Horizontal wells, infiltration galleries, and infiltration wells are vertical. They are vertical. Right? Then after that we have open wells and tube wells. This is a open well, or sometimes it is rectangular or square. Then we will be having tube wells. This is your tube well. Okay. These are all your sources of water. Just we have seen some images of sources of water. Now if you want to go through in detail about these sources, I have some points. This notes will be shared with you. The rains, no doubt, from the forms the principal and the major part of the results of supply. This is the rain is very important. This is the main source of the water. Okay, everything whatever you consider, it might be a surface source or subsurface source. What is the main reason? Because rain is the main reason. That is the this one main source. Since precipitation is the principal source of water on the earth, what is the, they will ask in the examination, what is the principal source of water supply, or what is the principal source of water on the earth? This is asked once, therefore it is underlined. This is your rain is the principal source of water. Okay. Now, always you remember in irrigation also we will study that the sum of all the water resources on the earth or in the earth is constant. Always remember the sum of all the water resources available on in the water is constant. Right? Next, the ponds and lakes are there. The ponds are natural large-sized depression. Ponds are what? Natural it is. Natural and large-sized depression will be there. And the earth, when it gets filled up with the water, it's known as a pond or lake. Then the difference between the pond and the lake is only that of the size. That of the size. Okay. If the size of the depression is comparatively small, it is considered as a pond. Okay, the size of the depression is comparatively small, then it is considered as a pond. When the size is larger, it may be termed as a lake. Right? The flow of water in a lake is just like a flow in a stream channel. Generally, the surface runoff from the catchment area contributing to the particular lake enters the lake through the small drains and streams. Okay, that water here, don't think like lakes are formed by the water from the groundwater. No, the main source for the lakes are the catchment area runoff. That is the main source. Sometimes the underground water through some springs, sometimes underground water from springs also enters natural depression and gets collected there, that forming ponds and lakes. Okay, this small amount of springs or otherwise infiltrated water will come for the this one. Then if I consider the quality of this water, okay, does not need much purification. Very important. This one, ponds and lakes, does not require much purification. Why? Because they act as a sedimentation tank. Okay, they act as a sedimentation tank, and the surface area will be very huge. Therefore, sun rays on the lakes and ponds will be more. Therefore, and algae formation will be there. Algae are good because they will consume the waste material present in the water, and they will purify water. Therefore, lakes and ponds are not required much purification. Larger and older lakes, this is very important. Larger and older lakes, however, provide comparatively purer water than the smaller and newer lakes. Okay, the old lakes means that is experienced lake, no? Then always experienced people are good, because experienced people are very humble and they know everything, where that everything. Okay, now like that here also, large lake and old lake, they are very purer than the small lake or new lakes. You know? Self purification of water due to sedimentation and suspended matter, bleaching of color, that is the removal of bacteria, etc., makes the lake's water purer and better. What here self purification process will be there, that we will study in the next subject, that is the wastewater. Self purification means the water itself purify its wastes. Then after that here the sediment, that lakes are acts as a sedimentation tank. And bleaching of colors, the color will be vanished because sun rays will be entering through the water. Then after that, removal of bacteria is also possible in this one. These are all the points which makes the lakes better. Okay, on the other hand, in still waters, the lakes and ponds, the algae and weed vegetable growth takes place freely. Okay, imparting a bad smell, taste and color. Okay, here algae will produce you a bad smell, taste and color, but algae will produce you oxygen also, DO also. Therefore, sometimes it is good and sometimes it is bad. You know, this one is also possible. Then when I compare the quantity, that is all about the quality. The quantity of the water, if I consider the catchment area of the lake basin, it depends on the catchment area. That catchment area must provide enough water, then only I can depend on that lake, or otherwise it is depending on the annual rainfall. If there is no rain, then there won't be any water collection in the lakes. And it is also depending on geological formation, dips, dikes, that cracks will be there in the rocks, rock beds are more permeable soil. This also depends. Okay, then very important, lakes are usually not considered as a principal source of water supply. They are not principal. What is the principal source of water supply means? That should be available whenever I demand. That is a principal source or main source of water supply. Okay, that is not the main source of water supply. Therefore, useful for only small towns and hilly areas. There only we can depend on that. However, no other sources are available. Larger lakes may become the principal source. However it is, don't worry about this one. Okay, then after that we have a streams and rivers. We have streams and rivers. In this streams and rivers, streams and rivers, that small stream channels feed their waters to the lakes and rivers. small streams are therefore generally not accumulate in the lakes, schemes, because the quantity of water available in this is generally very small. Small streams will be having water a small quantity. Right? Then we have then and they may even sometimes go dry also. Small streams there are they are therefore useful as a source of water only for small villages and especially in hilly regions. Larger and perennial streams may be however considered as a principal, right? Then rivers most important source. The rivers are most important source, that too perennial and non-perennial rivers are there. Perennial means what? That river will run for all 12 months. Okay, that. And perennial means, non-perennial means that will be running only in a rainy season, and most means it will be running in winter season. Okay, but in summer season these non-perennial rivers are dry, will get dry. Okay, these are all streams and rivers. And most important source, this point is then here, rivers are most important means here very very less purification is required, because the rivers are continuously in touch with the nature. Okay, and there will be ups and downs of the that waves will be ups and downs, therefore aeration will also be taking place, therefore they are very good. Then coming to the storage reservoirs as a surface source of water, here it might be a barrier. Okay, a barrier in the form of dam may therefore sometimes become constructed across the river. There is a river, then you will construct the barrier to that one, so as to form a pool of water on the upstream side of the barrier. Then this pool or artificial lake, okay, the dams are considered as artificial lakes and formed on the upstream side of the dam is known as storage reservoir. The storage reservoir is something like a lake only, but it is artificial lake, means man-made it is. There is a river and you are just putting some obstacle to the river and barrier to the river and storing the water. Then the quantity of this reservoir water is not much different from that of the natural lake. Natural lake, if it is a very big and old lake and big and old, sorry, this storage reservoir may give you somewhat same amount of water. Right? The quantity is equal to lake. Then we will come to the next water supply, water source, that is your surface, subsurface water, the underground surfaces. Okay, underground surfaces, that is the water which gets stored in the groundwater reservoir through the infiltration. The water will infiltrate through through the soil and it will be collected in the ground. Then it is known as groundwater. This water generally pure because it undergoes natural filtration. The groundwaters are very pure. That's why in well water, no, whenever you take a water from well, directly you can drink it. No? During the percolation through the soil pores, that will get a filtration. Then moreover, these waters are less likely to be contaminated by bacteria. Moreover, less likely to be contaminated by bacteria if that subsurface water are may have more minerals, more unwanted minerals, I can say, more unwanted minerals it can have, but this contamination will not be there, that is contamination by bacteria will not be there. However, they are generally rich in dissolved salts. Here it is there, rich in dissolved salts or minerals or gases. There might be that one, but the extent of the salts and minerals present in the groundwater depends upon the type and extent of the geological formation. It's not like the groundwater quality is same everywhere. No, the groundwater nearby that below your village, the groundwater that is available for your village, that might be different, and the groundwater available for my village is something different. The quality will be different because it is all depending on geological formation, type of rock, type of soil. That's all come. Sometimes the groundwater is brought to the surface by some natural processes like springs. Natural process like springs. Sometimes these water are tapped by artificial means by constructing the wells or tube wells or infiltration galleries. You know, you can bring that groundwater to the surface by artificial manner, or otherwise it might be a natural process. You know, this is what you are going to get about infiltration. Then we have a intake structures. Intake structures, just I am explaining, just I am giving you some names of the intake structures. This is a simple concrete block submerged intake structure. This is your water body, and the water will be entering here and it will collect, and from here the water will be pumped to the required place. Then we have another type one, rock filled timber crib submerged intake. This is submerged intake. Why? Because here this is completely rock filled, it is made, and this intake structure is submerged in the water. Then after that we have wet intake structures. Wet intake tower standing in the river. This is a river intake. In that river intake we have two types, wet intake and dry intake. You can see this is a water surface, water level, and we will construct here. Then there is a one shutter here and there is a hole here. And the water will enter here. You can lower this shutter so that you can close it, and here also some opening is there, here also opening is there. Means if a water level is this much, then you will open this upper opening, and if water level comes down, then you can open the lower opening. Like that you will make it. Then the water will enter inside. This water will enter inside like this, or otherwise like this, or otherwise like this, no, depending on the water level, and that water will be withdrawn. Okay, that will go to the next unit. This is your wet intake, and this is a dry intake. Dry intake because we don't have another chamber here. Here we don't have another chamber. Directly water will enter if the water level is here. If the water level is here, then the water will enter from here, then the water will be collected. Right? Then we have another one, that is a section of a typical twin well type of river intake. Twin well because two types are there. It might be very far from the surface, and here you have a ground surface here. You can see this one. There is a ground level here, and one intake structure. This is the intake chamber or intake well or inlet well will be constructed within the water body, and the sump well or jack well will be constructed away from the water body. Okay, the water will be supplied here, and after that the water will be pumped to the required place. Okay, then we have this one section of single well type of river intake be located across the offtake channel or otherwise approach channel. If you have any approach channel, then you can provide this one. Then you will be just water will be coming here, and after that you will be pumping. Then after that we have canal intake. You can see this is the canal body, and this is the slope of the canal. Then this is your, and the canal will go like this, you know? This is a canal intake. So there a small portion of a canal will be cut, and you will insert this intake structure. Then the water will come here, and there is something called as a fine screen, and through the fine screen the water will enter, and that water will supply to wherever required. Okay, in this canal structure we have a canal intake well. The same thing, sorry, two times it has happened. Okay, now these are all your intake structures. Then intake structures we have covered. Now we will be going through appendices. What are the equipments we are using in this water supply scheme? You can read this necessity of the water. Okay, then valves, very important. This is very very important. Valves are mechanical devices because the water will be coming from here, and you have to regulate that water. Therefore you will provide some valves here, opening and closing. Some valves you will be providing. Those valves I am listing here. In a water works practice, to control the flow of water, to regulate pressure, to increase, to release, or to admit air, prevent flow of water in the opposite direction, valves are required. For what purpose valves are required? That is water works practice, to control the flow of water. Okay, you want more water, less water, like that. To regulate the pressure. Okay, say for example, if less pressure, then the water may not reach the destination. Therefore, to control the pressure. Then to release or admit air. Okay, if any air bubble is inside, then you have to release that, and sometimes you have to give some ventilation so that the water can flow. Then to prevent the opposite direction, the flow of water in opposite direction, sometimes it happens, no? There is a water here, and the water, this is a pipe here, and the water is coming, and later the water may go back also by the effect is called as siphon effects. Okay, siphon effects. Siphon effect, the water may go backward direction. To control that one, you want valves. The functions of the valves are stopping and starting, reducing and increasing the flow, and controlling the direction of the flow, regulating the flow and process pressure, and relieve pipe system. So some pressure you can relieve. This is your sluice valve. The first one is sluice valve. Generally we will be uh, considered it as a stop valve. Then the flow is there, that flow you want to stop. If you stop the flow suddenly, then there will be hammering effect in the pipes, therefore you have to stop it very slowly. Okay, now then these are all sometimes known as a gate valve. Gate valves or stop valves or sluice valves are same. Okay, these points you can read. Next, sluice valves or stop valves, the image that how exactly this will be working inside, that is shown here. There will be one triangular knob. Triangular knob will be there here, and someone will rotate this one. When he rotate, then it will go upward. Then the water flow will takes place. You can lower it or that bring it to the upper. Then after that we have a check valves. Check valves are reflex valves. Reflex valves or check valves are something like this. This is your some arrangement is made here. When water comes here, this will open. Okay, here hinge is there here. One hinge support is given. Therefore, when water comes, it will open and the water will pass through. Then, if any reversal water is coming, then it will stop it this one. Okay, this is just like your cycle tube. In the cycle tube, if it is a tube, then you will provide one valve here, that how it will be cycle tube. This is your opening, and you will provide a one rubber here. No, then when you when you blow air, then air will enter inside, but the backing or the reversal effect will be stopped. That is your reflex valve. Okay, this is also called as non-return valve. These are also called as non-return valve, check valves ಅಂತ ಹೇಳ್ತಾರೆ. Then we have air relief valves. Air relief valves you will be observing in toilets. The commodes are there nowadays. The commodes are designed, and above the commodes there will be one box here. There you can see the air release valves. There will be one float. Okay, that float will be used, and this will release the air. Then after that, drain valves are there. Drain valves are then while cleaning. This is called as a washout valves. Washout valves, you want to clean the water and you want to clean the storage or otherwise pipes, then you will use a drain valves or blow off valves. Then zero velocity valves. Zero velocity valves are called as hammer arrests. Hammer arrests means sudden knocking effect will be there in the water. When you in your bathroom also you can see. Okay, whenever you, if you are in your bathroom, the pipes are of a steel one. If you are providing the steel pipes, then you will observe when you um, suddenly close the valve, suddenly close the valve of the tap, then you will get some sound in the wall, inside the wall, that cut 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 cut, that sound will be there. That is called as a hammering effect. That when you arrest the, that when you stop the water. Therefore, in bathroom, that is a small pipe, that's not a problem. But in practical things, when you are drawing water from dams and all, your pipe diameter itself 2 meter 3 meter. Pipe diameters will be 1 meter 2 meter 3 meter. At that time, if there is any cut like that, then many buildings will be that collapse. Therefore you have to take care of that one. Therefore you will provide hammer arrests, means that will arrest the hammering effects. These are our zero velocity valves. Then we have a scour valve. Scour valve means these are all similar to the blow valves. we are opening these cover valves at the time of washing, right? Then we have ball valves. Ball valves are something, there will be some ball here inside, and this ball valves even in our home also we are using nowadays. You can see this one, no? Nowadays the taps are something like this, you can see this one. This is your ball valves. Okay. Then fire hydrants are used wherever there is a fire. Fire hydrants is outlet provided in the water pipe for tapping water mainly in case of fire. Yeah, there will be, means fire walls will provide you high pressure, this one outflow, high pressure outflow they have to provide. Then we have water meters to measure how much water that it is supplied or otherwise distributed. Then we have a type of pipe materials. Then unlined metallic pipes, cast iron, galvanized iron, mild steel, ductile steel. We are using them as a water pipes, that is metallic pipes. Then we have non-metallic pipes, RCC pipes, pre-stressed concrete, water bar wrapped steel cylinder, concrete, obsessed asbestos cement, asbestos cement, and plastic pipes, PVC, polyethylene, glass reinforced plastic pipes, UPVC, like that we have. Here you can see the cast iron pipes, galvanized iron pipes, and these are all the type of pipes, reinforced concrete pipes, and asbestos cement pipes, then pre-stressed pipes, then polyethylene pipes, HDP pipes, there are all many types of bar wrapped pipes, like that we have many. Then here factors selecting the pipe material. How to select the pipe materials? No? Which pipe is suitable for us? Considering these all factors, you can go through them. Then we have essential requirement. Now we are entering into the next chapter, that is distribution system. See here, the water is collected from the intake structure. We have studied intake structures, surface and subsurface. In that one, after that the water is conveyed. Conveyed how? By using many valves, many using pipes, or many some equipments we have used, and after that water is supplied. That water is treated. That treatment will be studied tomorrow. No? That water is treated. Then treated water will be supplied. Then where it is supplied or distributed, then in distribution we have to study this one. Okay, means we are entering into the last chapter, that is essential requirement of good water distribution network. Then these are all the points you have to consider before designing the good water distribution system. Okay, now next, there are four types of distribution systems. The first one is a dead end system, radial system, grid iron system, and ring system. We will go one by one. Well, not we will go, you will go one by one, because this theory you just go through this one. Enough material is there here. Dead end or tree system, branch network. Here you go through this one, how it will work and all. Then after that, dead end or tree system, branch network, the same thing. The advantages and disadvantages are there here. Then radial system, advantage, disadvantages. Grid iron system, advantage, disadvantages. Then circular or distribution systems, that advantages and disadvantages over. Then the method of water distribution, how water is distributed. No, that we have a three types of distribution. The first one is a gravity system. Gravity system means, let us consider this is your water tank. No, the filtered water will come and collect here, but this is kept on the hill. This is kept on the hill, and you have a image villages here. That factory images or demand is created here. Then the water is supplied by gravity. This is a gravity system. Then we have another system, that is a pumping system. So this is a reverse case. Sometimes the water is at the bottom, then your need is in the top, then you will pump this one. Then combined gravity and pumping system. Sometimes what happens? Water is will be this one collected here in the lower portion. This water is pumped to the elevated tank. You will be seeing this one. Water tanks are will be there, not like this. Then you will be supplying the water to the elevated tank. From the elevated tank, the water is supplied by gravity. This is combined gravity and pumping system. Then these are all your water distribution system, advantages and disadvantages of that one. Then pumped systems, that advantages, disadvantages. combined gravity pumped systems advantage disadvantages. Right? Any doubt? Put the heading quality of water. ಈಗ ಇಲ್ಲೇ ಇರ್ರಿ ಎಲ್ಲಿ ಹೋಗ್ಬೇಡ್ರಿ ಥಿಯರಿ ಅದ ಭಾಳ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಇರ್ತದ ಡೋಂಟ್ ಮೂವ್ ಹಿಯರ್ ಅಂಡ್ ದೇರ್ quality of water. Okay, there are three qualities we are discussing. The first one is physical characteristics, physical characteristics of water, and the second one is chemical characteristics, and the third one is biological characteristics. PCMB ಒಳಗ M ಇಲ್ಲ ಅಷ್ಟೇ PCB ಐತಿ right. Physical characteristics, chemical characteristics and biological characteristics right. Now the first one is physical characteristics. In this physical characteristics we will be discussing, put the heading physical characteristics. The first one is turbidity of water. The second one is color of water. Third one, taste and odor. Taste and odor. The fourth one is temperature. The fifth one is dissolved, not dissolved solids. Taste, odor, color, temperature, specific conductivity. Over. Okay. Specific conductivity. Okay. The first one is a turbidity. The first one is turbidity. This is a obstruction to the passage of light. Definition of turbidity is passage. This is a obstacle to the passage of light or scattering of passage of light. Let us consider I have water here. I have water here. Then if I have a torch also here. This torch is put on the water. Then this water, if it is clearly coming this side, then I can say that this water is with zero turbidity. Zero turbid. Okay. If these lights are scattered like this, if these lights are scattered here and you are not able to see the exact the light, exact you cannot see, means this is not a transparent now. It is not transparent. It is a translucent. Translucent means light is scattered here. Means you are seeing but seeing with a blur. Then we will call it as a water is turbid. Water is turbid. Then the first thing is that why there is a turbidity in the water, causes. Why we have a turbidity? The causes. The causes are it might be particles like clay, silt, or fine sand, and there might be some organic matters, or it might be because of some algae and all. These are all the impurities. These impurities may be present in the water, therefore we have a turbidity. Okay. Then how this turbidity is measured? Now I will show you one PPT. I will remove this. Okay. First we will discuss this one. Now we will go, later we will go to the characteristics. The first one is different names for the water. The first one is a pure water. Pure water means it is H2O. Then we have another name called as a potable water. Potable water means drinking water. Okay, drinking water means you can drink that water. Don't think that all minerals are present. No, drinking water. The water is eligible for drinking. Then palatable water. We have another water called as palatable water. This is aesthetically good, but may not be used for drinking. Aesthetically good, but may not be used for drinking. Right? Wholesome water. Wholesome water means doesn't contain harmful content. It will not contain any harmful content. That's it. Okay, can we drink? No, I will not tell you to drink or not to drink. Right? Just I am telling you that it doesn't contain any harmful content. Okay, you can use it for face wash, or otherwise that washing the utensils, or you can use it for bathing, or that for any other purpose, domestic use, you can use them. But drinking, I will not tell you whether to drink or not. Okay, if you don't have any source at that day, then you can drink, because it doesn't contain any harmful water, this one content. But this aesthetically good is very danger. Okay, the water may be aesthetically good, may contain harmful contents also. Okay, there might be poison in the water but looks good. No, there might be poison in the water but looks good. That is just aesthetically good, palatable water. Then polluted water. Here we have two different words: polluted water and contaminated water. Polluted water means it has a undesirable substances. Undesirable substances like sand, silt, clay, leaves are there, and organic decays are there. These are all undesirable substances are there. Plastic is there, rubber is there. These are all polluted water. Then contaminated water means it has a organic, specially it has a organic, and specially it has a bacteria and pathogens. These contents are there in the water, then it is called as a contaminated water. Then we have a mineral water. Mineral water means it contains required minerals for humans. Humans, how much mineral is required? Say for example, fluoride is required from this much to this much, iron is required this much to this much. Then hardness, pH, these are all alkalinity, acidity, that all the things are measured and it is kept in the water. Then that water is called as a mineral water. Mineral water is not a pure water, always remember. Okay, mineral water is not pure water. Pure water means just H2O, distilled water you can call. Distilled water is a pure water. Right? See, here some questions are asked like this: what is water is said to be contaminated if it contains, Edri, which option?
A.
Pathogens.
Water is said to be contaminated if it contains pathogens, undesirable suspended matters, making it unfit for drinking and domestic, then dissolved salts. Out of this, A is the correct answer. No? Then pick up the incorrect one. Contaminated water is always polluted. Polluted water is always contaminated. Absolute pure water is not good for health. None of the above. Incorrect one you have to.
Polluted water is always.
Polluted water is always contaminated. No. Incorrect we have to select. No. Correct. Okay. Polluted water is always contaminated is a wrong statement. Contaminated water is always polluted. Okay, this is a right statement. Then absolute pure water is not good for health is also right statement. Therefore, this is a wrong statement. Incorrect one we have to select. Right? This one, polluted water is the one which.
Option B, sir.
Option B is the correct answer. Correct? Then wholesome water is the one which does not contain.
So D.
D. It does not contain pathogenic bacteria, correct? Then suspended matter in quantities harmful to man, correct? Dissolved matter in quantities harmful to man, that's correct. Therefore, D is the correct answer. No? Over. Now, such questions they will ask in that concept. Now we have three characteristics. We are already discussed this one: physical characteristics, chemical characteristics, and biological characteristics. We will go one by one. As I told you already, that is a turbidity, color, taste, odor, then temperature and specific conductivity. These are all physical characteristics. Now comes the turbidity. Turbidity, the causes are the causes of turbidity are silt, clay and sand, then finely divided organic matter, algae, fungus and bacteria. These are all causes of turbidity. Then how to measure a turbidity? How to measure a turbidity? We have one scale called the silica scale. What is the silica scale? That silica scale means this you can consider, this diagram you can see. This is one, you can consider test tube or otherwise a bottle of water. Silica scale means, I will explain here, that is 1 milligram of silica. Silica andre no sand. Silica means something just like a sand. Sand is a silica, right? 1 mg of silica dissolved in dissolved in 1 liter of water. 1 liter of water. That is called the silica scale. Then what is the 1 unit of silica scale? 1 unit of silica scale is nothing but 1 mg per liter. 1 mg per liter. Okay. 1 mg per liter. This mg and liter. See here always 1 kg of water. 1 kg of water is nothing but 1 liter of water. You always remember this one. 1 kg means 1 liter. Therefore, 1 kg and 1 mg, compare. This is a milligram and this is the kg. Milligram converted to gram, then gram converted to kg means here to here 10 raised to 3 and here to here 10 raised to 3 means mg 2 kg is 10 raised to 6. 10 raised to 6 is considered as a million. No, it is considered as a million, capital M. Therefore, 1 mg 1 mg compared with 1 liter means it is 1 part in 1 millionth part. This is a 1 millionth part of the liter. Therefore, 1 mg per liter and ppm both are same. What is ppm? ppm is parts per million. Parts per million and mg per liter both are same. Understood? Now you can see the diagram here. This is a 10 silica scale. These are diagrams of silica scale. 10 mg per liter of silica means this much. It will look like this. Then 25 mg per liter of silica look like this. 50, 100 and 250. See here. 250 if turbidity is 250. No? Turbidity is 250, then the water will look like this. Okay, turbidity 100 means water will look like this. Turbidity 10 means water will look like this. No? Now very important point we have to note it down. Very important point we have to note it down. The first point is for
Sir, can
drinking.
you please repeat the previous one, sir?
Which one?
That conversion, the ppm to milligram per liter.
Okay, that conversion now. Okay,
Yes,
now
sir.
look at here. Always the water density is 1 kg of water means 1 liter of water. 1 liter of water. No? Then here 1 kg means how many gram? 1000 gram. Then 1 gram means how many mg? Then 1000 mg. 1000 mg means 1 gram. Then 1000 gram means 1 kg. Means in 1 kg how many mg will be there? Then 10 raised to 6 mg will be there. Okay. Then this is 1 mg means 10 raised to 6th of kg. 10 raised to 6th of kg. Therefore, I am comparing this mg with the liter because 1 kg means 1 liter in water because density is 1. Therefore, whenever I write mg per liter means I am considering one part of the millionth. Therefore, this is considered as a parts per million. 10 raised to 6 means what? That is million. Therefore, therefore it is considered as a parts per million. Therefore, ppm ppm is nothing but mg per liter. Any doubt?
No, sir.
Okay, now tell me what is the meaning of ppb?
Parts per billion.
Okay, parts per billion means how many mg per liter?
So 10 to the power 9.
I am asking mg per liter, no? 10 to the power of 9 is a billion. Therefore, you have to answer it like this: 0.001 mg per liter. Okay. Whenever, say for example, it will come, say a copper content in water. How much? What is the desirable limit of copper content, or arsenic, lead? They will come. Then what is the copper content? If I say 0.001 mg per liter, this is very looks very odd, no? Then you can call it as a 1 ppb. 1 ppb. You can call it like that. Later we will be seeing that one. Right? This one is clear. Now we will go to the turbidity. Now you just remember this one. For drinking water, the drinking water, 5 to 10 ppm is allowed. For drinking water, 5 to 10. Look at here, this bottle water can be drinkable. Always remember. ಒಂಡ್ ನೀರ್ ಅಂತ ಇರ್ತಾವ ಗೊತ್ತೈತೆ ಊರಾಗ, ಹಳ್ಳಿ ಒಳಗೆ ಹೋಗಿರ್ತೀರಿ, ಬೋರ್ ನೀರ್ ಬರ್ತಾವ, ಬೋರ್ ನೀರು ಅಥವಾ ಮನೆಯೊಳಗೆ ಒಂಡ್ ಇರ್ತಾವ, ಒಂಡಿದ್ರು ಕುಡಿತಾರಿಲ್ಲ, that is your 5 to 10 ppm is allowed. Then naked eye can see more than 5 ppm. Always remember. If I put one bottle of water here and where this one 5 ppm turbidity is there, means that you can observe it. Look, any turbidity below 5 ppm cannot be observed by our eyes. Turbidity is there, but you cannot observe that turbidity. So the naked eye can see only 5 ppm. And here one more point, you write it down. Here it is not included in this one. This 25 is there, no? Lake water will have turbidity. Lake water will have a turbidity 25 ppm. Okay, lake water will have a turbidity 25 ppm, and mud water will have a muddy water. If I say muddy water, then muddy water will have a ppm, that is 100 ppm. 100 ppm. Right? Now we have a instrument how to measure this turbidity. We have a unit called as a JTU, Jackson Turbidity Unit. Jackson Turbidity Unit look like this. Then this is designed by the scientist called Jackson. Therefore it is like this. Then here we are keeping one candle here, and there is a one that candle light. Then after that there is a jar here, transparent jar. We will put a water, and with the help of our eye we will be seeing this, seeing through that one. And you go on putting the water, go on putting this water, and stop it when you are not able to see the candlelight. Okay, when you are not able to see this candlelight, stop that and read the readings which are written on the this cylinder, this jar. The readings whatever that is written on the jar will give you the JTU. Right up. This JTU is used for high turbid water. JTU is used for high turbid water. Now give me answer. If this is a jar and I have another jar here. Now look at here. Your experiment is stopped. Your experiment is stopped when I put this much of water here, and your experiment is stopped when I put this much of water. Then which is more turbid, A or B?
Hey, sir.
A. Right.
Everyone will agree that is A means it is a more turbid, because this much of water you have put and your light is not visible. Therefore this much of water you are putting means the light is visible. Means if a jar height is this much, and the that turbidity which is less than 25 ppm, the less than 25 ppm, that water if you go on putting, then the light is visible even the water is this much. Therefore, this container is limit is this much only. No. Therefore, this is not able to read less than 25 ppm. Therefore, Jackson turbidity is used only when turbidity is more than 25. It will not read below 25. It will not read below 25. More than 25 it can read. Right? That is the limitation. Then what we have to find a solution for this one. No? We have to find a solution. Then how to read the turbidity below ppm, below 25. Then we have a another meter, that is a turbidity nephlometer, nephlometric turbidity unit. Now look at here, in the examination they may ask you what is the difference between turbidity and nephlometry. Nephlometry is different, turbidity is different, but both have a same principle. The first one is a turbidity, that is a radiation, and nephlometry means scattering of intensity of the light, scattering effect. See here, I have one test tube here, and I have another test tube here. Let us consider the light is coming from here, the light is coming from here. Then here you have sent some radiations, and you are able to see how many radiations are coming out. Then this principle is called as a turbidity. Then scattering means here you have sent some intensity of light, and here some other intensity of light is coming. Then the light is scattered. Therefore, that is scattering of the intensity of the light. Just remember, wherever the word radiation comes, that is a turbidity. Wherever the word intensity of light will come, that is a nephlometry. Nephlometry. Then we have a NTU, another unit called as a NTU. Now tell me, JTU is based on turbidity or nephlometry? JTU is based on turbidity or nephlometry?
Turbidity, sir.
Turbidity, because here the radiations, you are seeing the radiation, not scattering. You are not studying the intensity of the light. But that's why we have another instrument that is called as a NTU, and in this NTU, that is a big instrument. There you can see very low turbidity. See, very impossible to see or through our naked eye. 0 to 1 ppm you can study. That this much low turbidity we can read. And we have ballast turbidity meter. Another scientist has discovered this one. It has a it can read 0 to 2 ppm of turbidity. Okay, na? Then now we have studied everything about with respect to the first one. Just go through this one. The first one I told you about this one, one scale of silica, silica scale. Do you know how this is measured, silica scale? I'll explain you like this. Earlier, before Jackson also, the turbidity used to be measured like this. One test tube, another test tube, another test tube, test tube, test tube, test tube, test tube, test tube, test tube. Here, a water, plain water, that is your distilled water they will put here. Then here they will add 1 mg of water, 2 mg, 3 mg, 4 mg, 5 mg, water alla, 1 mg of silica, 2 mg silica, 3 mg silica, 4 mg, 5 mg, 6 mg, 7 mg, 8 mg, 9 mg, 10 mg of silica. Then what you do, you will bring your water sample here. This is your sample test tube, water sample. This water sample is compared with this one. Compare, not matching. Compare, not matching. Compare, not matching. Compare, yes, matching. Then I can say that this is a 5 ppm. See, this is called as a calorimetric test tube. By using a not calorimetric, ಇದಕ್ಕೆ ಏನಂತಾರಲ್ಲ, ಕ್ಯಾಲೋರಿಮೆಟ್ರಿಕ್ ಅಂದ್ರೆ ಕ್ಯಾಲೋರಿ ಮಾಡ್ದಂಗೆ ಆಗ್ತದ. ಇದಕ್ಕೇನೋ ಒಂದು ಹೆಸರು ಅಂತಾರ ನೋಡ್ರಿ, ನೆನಪಿದ್ರೆ ಹೇಳ್ರಿ, ಇಲ್ಲಾಂದ್ರೆ ಹೇಳ್ತೀನಿ ಆಮೇಲೆ. ರೈಟಾ? ಅದು ವಿಡಿಯೋ ಹಾಕಿರ್ತೀನಿ, ಅದು ವಿಡಿಯೋದೊಳಗೆ ಅದು ಟೈಪ್ ಮಾಡಿ ಹಾಕಿರ್ತೀನಿ. ರೈಟಾ? ದಟ್ ದಿಸ್ ಇಸ್ ಸಮಥಿಂಗ್ different. But after this is very difficult, no? Because you have to make many test tubes, and after that you have to compare. That's why our Don came. That Don name is Jackson, and he invented this one, Jackson turbidity meter. Then after that many people came, they invented nephelometric and ballast turbidity meter. Then after that one more is coming, that is a pharmazine. Pharmazine is the another powder it is. Just like you have used the silica, no, 1 mg of silica, like that. This is a silica. Then another powder is there, that powder is very finer than the silica, that powder is called as a pharmazine. Then this powder is also used for the measurement of turbidity. 1 mg of pharmazine is considered as a 1 ftu. 1 ftu. Now if you want to compare this 1 ftu, then see here 1 ftu equal to 1 ntu, but 1 mg per liter of silica solution is nothing but 3 ntu. Always remember, one scale of one scale of silica is nothing but 3 ntu, 3 ntu or 3 ftu. You have to remember these units. Right? This is all about turbidity. Then next we have a color. Then the reasons for the color is dissolved organic matter or decaying vegetations, growth of algae, and some inorganic colored soils. These are all, and metallic ions. These are all the causes of color. Then in this one, color also measured by with some scale that is called as the platinum cobalt scale. Okay, platinum cobalt scale you can look at here. This is a platinum cobalt scale. Okay, here I didn't write any numbers here, just like in turbidity I wrote. No, here I didn't write because exactly we will not get through this figure. This is a color, no, that's why. And you can go on, see here, roughly I can say this is 1 mg per liter of cobalt, 2 3 4 5 6 7 8, like that, no? Then increasing the cobalt, then your sample will be here. This sample is compared, not matching, not matching, not matching, yes matching. Then your color is 4 ppm. Your color is 4 ppm. Then the machine, electronic devices we have nowadays invented, that machine used or the instrument used to measure the color is called as tintometer. Tintometer, understood? Then after that we have a taste and odor. The causes of taste and odor are dissolved organic matter, inorganic salts, and dissolved gases. Dissolved gases, these are all causes of taste and odor. Okay, here, no, not this one, platinum cobalt, right? Taste and odor. Then how to measure this taste and odor? Okay, the instrument used to measure the taste and odor is your tongue. Taste get tongue, and instrument used to measure the odor is nose. That's why we have to use these two organs only to measure this one. How to measure this one? See here, I'll take an example of lemon. This is a lemon. Let us consider that is your threshold number. We will call it as a threshold number because we don't have any scale here. Because we cannot compare it by using your some test tubes, sample and calibrated test tubes. That is not possible here. Here what we have to do is you take your water sample. Let us take 1 ml of lemon juice, and I want to measure the taste of this lemon. See, I want to measure the taste. What I am saying, measuring the taste. This 1 ml of lemon, I will put it into distilled water. See, this is 100 ml of lemon water. This 100 ml of water, then I will put this lemon here. Then after that I will stir it. Then I will check the taste of this one. If you are seeing any sour taste, then you go on adding water again. Go on adding water. Go on adding water. How much water you have to add? You have to add till the taste must disappear. The taste must disappear. You should not taste the water. Taste the sour. Then that much water you have to add. Then you use this formula, that is A means your sample. How much sample? 1 ml of sample. B means you are using this 100 ml. Then 100 ml of water you are using. Divided by A means 1 ml. Then your answer is 101. This is your threshold number. This is your threshold number. Then I can say that this lemon has a threshold number of 101. Threshold number of 101. Okay. Now, what is the limit for drinking water? Drinking water, the taste for the drinking water is 0 to 3. 0 to 3 means 1 ml of bad water must lose its complete taste when I add 2 ml of good water, that is distilled water. When I add this to a plus b equal to 1 plus 3 divided by 1 is equal to 1 plus 2 divided by 1 is equal to 3. 3 by 1 is 3. Now it is somewhat good. Understood? Huh? That's why it is called as a threshold flavor, threshold number, or threshold odor number. Now I discussed about taste of the water. Na? Then how to measure the odor of the water? The same thing. You take a water here and smell this one. Use your nose, use your nose and smell it. Okay, then record in your mind. Then after that you add it into a distilled water, then stir it, then after that again use your nose, then smell it. The smell should disappear. Then use the formula a plus distilled water divided by a, then you will get this. Then again threshold odor number is also 0 to 3. Okay, now after that we have a temperature. The temperature is because of heat or cold. Heat or cold. Then the thermometer is the instrument used for the temperature to measure the temperature. Desirable limit is 10 degrees centigrade. For drinking water, 10 degrees centigrade. Specific conductivity. Specific conductivity means there are some salts are there. Salts are of organic salt or inorganic salts are there. Say just an example, NaCl. NaCl is a salt, right? This when I put this NaCl into the water, then Na becomes separate plus and Cl become separate. Then Na and Cl are separated. Then the same thing when I put a electric current here, electric current of means E minus, then this E minus will be transferred because these are all ideal, no, berojgar. No, they don't have any work to do in the water because here when they are NaCl, when they are in the this one container, they are just NaCl, but when they added a water they got a freedom and they don't have any work to do, therefore they will conduct the electricity, they will conduct the current. That's why this whenever there is a organic or inorganic salts are dissolved in the water, then it will conduct electricity, therefore it is considered a specific conductivity. Uh, Dionic water tester is the instrument. Diionic water tester is the instrument. It's not a desirable limit. Okay, we don't have a desirable limit here, just you need to identify the conductivity, that's it. Okay, very important, it can be used to measure the extent of dissolved solids. What do you think? If there is a distilled water, then if I put one wire here and this is connected to current and another wire here, will this water will transfer the current, distilled water? The answer is no. This water, distilled water, will not pass the current through that. But when you have a mineral water, when you have mineral water, then you can transfer that current here because here the unsatisfied salts, they will transfer the water. Therefore if your current is transferring, current is passing through the soil means passing through the water means what, it can give the extent of dissolved salts means there is a salt inside them. Then all dissolved salts are not conducting. There are some dissolved salts, they are not conducting, therefore few dissolved salts are only conducting. Therefore you will not get a exact amount of dissolved salts, you will get a extent of dissolved salts, very important. You will get just extent of dissolved salt, you will not get a exact amount of dissolved salts, that you remember, right? You make this chart. This chart so that for competitive exams it will be easy. Turbidity, you write a causes here, then you write a scale here, unit here, instrument used. Instrument in turbidity you write all JTU, NTU, FTU, BTU, you write. For all of them desirable limits, drinking and those limits you write. If you want any remarks you can write. Like that color also, taste, odor, temperature, conductivity. You make one table and keep it ready. That is very useful. है ना? This is all about physical properties. Any doubts in the physical properties? If you have any doubts, you can ask in physical properties. Huh? No doubt. Okay. Then we will go to the chemical properties. Okay. We'll take a small break. Then we will go to the chemical properties. I'll mention the time here. Now it is 9:52. We'll gather at 8 minutes, 10 o'clock. Sharp at 10 o'clock. Okay. There is a 8-minute song will be playing, and that song whenever it stops, then I will be here. Chemical characteristics. See, these are all chemical characteristics. The first we have to discuss about total solids. Total solids. Then we will discuss pH of water, hardness of water, nitrogen content, chloride content, metals and other chemical substances, dissolved gases. Okay, these are all your chemical characteristics. Right on. Now, one by one we'll go. Total solids. Total solids means just like a turbidity or color, whatever it is. Solids are present in the water. Okay. This is included in the chemical characteristics because of chemicals also there will be some solids developed in the water. Now total solids is divided into two types. The first one is a total suspended solids and the second one is a total dissolved solids. Total suspended solids means what? See here, this is your suspended solid. If you allow it for about 1 hour, 2 hour or 3 hour depending on the this one intensity, then after that what happens, this mud will settle down. Now how it is, this is suspended, means it is floating here and there, therefore it is suspended solids. Okay. Then dissolved solids means you keep it for 24 hours also, 1 month also, then these solids will not settle down, they are dissolved in the water, therefore this is called as total dissolved solids. Okay, now this total solids, how to determine this total solids? I have an experiment, that just experiment is a small simple experiment. I will take one container and I will take about 100 ml of water, 100 ml of dirty water. This water I will put it here and it has a solids here. This solids is considered the total solids. Then I will put a fire here, then I will evaporate all this water. This all water is evaporated. No? Then when I evaporate all the water, then something will be left at the bottom of the tank, no? This container. Here it is something left. Then I will measure this one, how much it is. If it is a 20 mg, 20 mg of the solids are present, then I will have a equation 20 mg I found it in 100 ml of water. Then you convert this one 20 mg 20 mg in how many liters? 0.1 liters. Then how much it is? The answer is 20 divided by zero point 0.1 is 200 mg per liter is your answer. 200 mg per liter is your answer. That much of total solids you have got. Right on. Now, how to find the dissolved total suspended solids? Suspended solids. Then I will use one paper. It is called as Wattman filter paper. Wattman filter paper. This is the round color, round shape filter paper will be there. That I will use it and I will filter the water. Okay. Then after that, this filter paper, earlier it was just a pure one, there won't be any stains here. Then after that there will be solids stuck, they are arrested in this filter paper. Then I will measure the earlier measurement and later measurement, then the difference of these two, then I will get a solids, that suspended solids present in the water. Then look at here, if this answer is 120 mg per liter, if this answer is 120 mg per liter. Now look at here, what happened here is, see, The total solids I calculated and I got 200 mg per liter. 200 mg per liter. By filter paper, I got this suspended solids, that is about 120 mg per liter. Then difference of these two, that how much is left? 80 mg per liter. That 80 mg per liter, I can say that it is a total dissolved solids. Over. This is the determination of three types of solids. Any doubt? Do you have any doubts?
Sir, sir, the dissolved solids, ಇನ್ನೊಂದ್ಸಲ explain ಮಾಡಿ.
Dissolved solids is the difference between these two. Okay, dissolved solids means that is just like a salt. Okay, you take a water, you take some water, then you put 1 spoon of salt into this one, or sugar you put it, you know? Then this sugar or salt, see, earlier it was 100 ml of water, then you added 2 gram of salt, then this becomes what? 2 gram means 2 ml, just I am comparing 100 mg of 100 gram of water and 2 gram of salts, total it becomes 1 or 2. Means in a salty water there is a solids, in salty water also there is a solids, those solids are considered as a dissolved solids. But how to measure that one? Because it is already melt inside, no? That is melt. Therefore what you do, you take that salty water and heat it, then it will be left in the container. Because while when you heat that, all water will go away. Means when you heat, you will get dissolved solids also, suspended solids also. Therefore it is called as a total solids. Then this total solids is 200 mg per liter. If it is, then suspended solids you get it by filter paper, then the difference of these two will be your 80. That is your dissolved solids. Any doubt?
No, sir.
Okay. Now do this problem quickly. What is pH? pH is a measure, no? Say, I will come to directly because I will not spend much of the time explaining all the concepts. You already know that pH means there will be some scale. The scale is will start from 0, and that is a 14 here. There is a 7.
14.
Huh? Okay, 0, 7 and 14. And this side we will call it as the acidity. If the pH value is from 0 to 7, it's called as acidity, and this one is called as alkalinity. In PUC, I think in pre-university study you might be called it as a base, acid and base, but don't call it as a base. It is a alkalinity. Acidity and alkalinity. If the pH value is 7 to 14 and 0 to 7 is acidity. Now, what is a pH? pH is just a number. It don't have any meaning. Always remember, pH is just a number. That is the power of hydrogen. That is nothing but negative logarithm of H plus ion concentration. H plus ion concentration. Or some textbooks they will write it like log of 1 by H plus ion concentration. This is also right and this is also right. Then what is a POH? POH is a OH concentration. That is also a number. That is your negative log of OH concentration, OH minus concentration, or otherwise it is a log of 1 by OH concentration. Right? Then you should know that pH plus POH is equal to 14. This number you should know. Okay, now then from this one you can determine whatever, that if pH is known, then H plus ion concentration you can calculate. If H plus ion concentration is known, then pH you can calculate. Vice versa you can play. Now if I say pH is equal to 3, then what is POH? POH equal to 11. like that you can play. Right? Any doubts here? Okay. Now, as I told you that acidity, sorry, pH means it is a measure of acidity. Acidity, right? Why there is a acidity in the water? The question is why we have acidity in the water? Because of what? Write it down. Because of these parameters. Okay. The first one is acidity is because of mineral salts. Mineral salts. Acidity is because of CO2. It is because of H plus ion concentration, and it is because of absence of OH concentration. Okay, these are the four reasons. Because of these, the water has a pH, that acidity. Any doubt? No doubt. 1 minute. Just wait for 1 minute. We'll do one thing. Okay. Today I didn't get a time to prepare this one. I have excellent notes. I was searching that PDF notes. No, just I explained this PPT. No, the same way I have excellent notes. That notes I will make a cam scan. I will make a PDF. That PDF I will share with you, and I will explain along with the notes. No, that notes I have here now hard copy. No, clicking the photo and compare converting takes a time. That's why we'll stop here and we'll solve some problems and we'll end the today's session. Okay, now till now whatever we discussed, if any questions are there from previous year, those things we'll discuss. Remember this pH value and chemical properties we'll discuss tomorrow, and we'll enter into filtration also. Right? Now we'll go to the questions. If any questions are there which are covered, then we will cover it here. Okay, this question, can you answer this question? Water supply includes collection, transportation, treatment of water, distribution of water to consumers, provision of hydrants for fire lifting. All the above?
All the above.
Okay. The distribution system in the water supply is designed on the basis of, tomorrow it will come. tomorrow that will come. This one. In a groundwater, the muddy or cloudy appearance of the clay or such other uh, particles that presents hindrance to the path of light is measured by. Path of light is measured by.
Jackson.
Jackson turbidity meter.
Why not T1 turbidity meter? We don't have anything called T1 turbidity meter, right? Therefore, Jackson turbidity meter is the correct one. Next, 2.2. The total solids in water are due to presence of.
Suspended and dissolved solids.
Correct. Okay, suspended and dissolved solids. Okay, whatever the meanings of this colloidal bacterial load. Okay, don't worry about this colloidal and bacterial load. Here is there a suspended and floating solids, colloidal and settleable solids. These terms we will use it in a wastewater management. Here this is a total solids in water they are asking, therefore C is the correct answer. If they are asking total solids in wastewater, no, then that is a different answer. But that answer is not here. But always think total solids of wastewater is different. Total solids of water is different. Okay, now next 2.3. At the low pH, the contact period required in chlorination. Okay, chlorination we'll think later. Disinfection, permanent algae. Huh. 2.15. The measure of absorption of or scattering of light by suspended material present in the water. Correct? Light, but color is there. You always think here. Color will not scatter the light. It will scatter, but not like a turbidity. It is called as absorption or scattering of light by the suspended material, not dissolved material. By suspended material, therefore turbidity is the correct answer.
So 2.13 also we can do, I guess.
2.13. No, 2.13, there is a sequence I was remembering. Screening, filtration, sedimentation, disinfection. Screening, disinfection, sedimentation, filtration. Which one you want to answer? More suitable for treating the raw surface water. I have to give you a chart for treating of surface water and subsurface
D.
water. There are two types of the sequences will come. Okay, that I will explain
D we
later.
can.
Hmm?
Okay.
No.
D we can.
D. Surface water is there. Screening first, sedimentation, filtration, disinfection. Okay, right. Okay, we'll see that one later. Next, which of the following? This one, 2.4. Which of the following is a chemical characteristics of water?
D.
D. Okay, BOD is a chemical characteristics of water. Okay. This is a BOD. Hmm. 2.43. In which of the following systems of water distribution, water can reach a particular point only through one route, and any damage or repair at a point in a pipe's line will completely stop the water supply in the area being fed by the pipe beyond the point of damage or repairs. ಅಂದ್ರೆ
A.
this is the demerit of that system.
Dead end system.
Hmm?
A. Dead end system.
Correct answer. Dead end system. Dead end system is a very inefficient system. Okay, that you can remember. Next, here 2.58. The valve used for prevention of reversal of flow in the pipe is called.
Check valve.
Check wells.
Check valve. Okay, this one it's not told. The permissible limit of total dissolved solids in drinking water in the absence of alternate source is
500.
no 2000.
The absence of 2000. Okay, okay, sir.
Yes, yes. That was a this one desirable limit and permissible limit like that too will be there. No, this is also there,
Yes,
but
yes, sir.
in the
Permissible
absence
limits.
in the absence of alternate source, you have to answer. Right?
Okay, sir.
Okay. These are all. This comes under biochemical. This one wastewater that we will see later. If anything is missed here. Okay, right. Okay, now.
Sir,
Today, now only, I will put a few more objective questions are there. Those objective questions are on today's topic. About 20, 30 questions are there. Just now I will click and make a copy and send you. Okay. Anything want to ask?
sir, if
Hmm.
it is asked that the lowest of the turbidity can be measured by the options are Baelish and Nephelometer. We
Hmm.
have to we can choose Nephelometer, right?
NTU. NTU is 0 to 1. No? That one we
Yes,
can. But Balance is 0
and
to 2.
two.
0 to 1 we have to select.
Okay.
Okay.